All right, pre-calculus, we're moving back into some more physics. We are in lesson 6.5, and we're talking about trigonometric form of a complex number. And our essential question today is, how do you represent and perform operations on complex numbers by using trig? So we're going to look at this. This is new to us, the complex plane. Notice the real axis is what we used to call the x-axis, and the imaginary axis is where we used to have the y. So the imaginary are going to be the ones with the eyes, and the reals will be the ones that are constants that stand alone. So if I have to graph 3 plus 2i, I'm going to move 3 on the real and up 2 on the imaginary. So you probably get it. You've seen this stuff before. It's kind of like graphing in a Cartesian coordinate system, but we're not. And if I graph negative 1 plus 3i, I'm going to go negative 1 on the real axis and positive 3 on the imaginary axis. And same with our last one here. At negative 2 minus I, we're going to go negative 2 on the real and minus 1 on the imaginary. The next thing we're going to take a look at is the absolute value of a complex number. A plus bi is defined as the distance between the origin, 0, 0, and the point. Z is equal to a plus bi, and this is given by the absolute value of a plus bi, which is equal to the square root of a squared plus b squared. So let's read this first question. It says, plot 3 minus 4i and find its absolute value. So I'm going to keep that little formula right up there for us. If I'm going to plot positive 3 and a negative 4 on the imaginary, I need to know where that is. And then to find the absolute value, remember I'm taking the square root of 3, squaring it, and negative 4 squaring it. And how nice that this one turns out as the square root of 9 and 16, which we know is the square root of 25, which is 5. That was very nice and user-friendly. Moving on to the trig form of a complex number. If we have the trig form of a complex number, the trig form z equals a plus bi is given by z equals r times the cosine of theta plus I times sine of theta, where a is equal to r cosine theta and b is equal to r sine theta. R is equal to the square root of a squared plus b squared, and tan of theta is equal to b over a. Well, that is a lot of information in one little spiel. So let's go ahead and put it to practice and see how we do. The number r is, sorry, I thought I had a highlighter. The number r is the modulus of z, and theta is called the argument of z. So r modulus theta argument. So example 2 says write z is equal to negative 2 minus 2 root 3i in trig form. Now the first thing is I see there's a little mistake here. This root should not be over the I, so I'm just going to erase that. Does that look erased if I put a yellow through it? So the first thing that we have to do is we have to go ahead and find the absolute value. So I know that r is equal to the absolute value of negative 2 minus 2 root 3i, and that's going to be negative 2 squared plus negative 2 root 3 squared, which is, let's see, 4, and 2 squared is 4, times 3 is 12, so that is the square root of 16, which is 4. So that is the R, the modulus. Now, we have to use the information that we see, and I'm going up here to the tangent of theta is equal to b over a. So I know the tangent of theta is equal to b, which is negative 2 root 3, over a, which is negative 2, which becomes root 3. Because we know that root 3 is at tangent where it's pi over 3 on the unit circle, and z is equal to negative 2 minus 2 root 3i. So if I had to graph this point right here, I was trying to keep the equations up, but this is all I really need. If I needed to graph that, I know that this is at negative 2 and minus 2 root 3i, so that's going to be in the third quadrant. So we have to know where it's going to be. So because of my information of the unit circle, we talked about how pi over 3 is the tan of pi over 3 is equal to the square root of 3. So I know that I have to go the whole pi, and then I have to continue another pi over 3 to get to where this point would be. So if I take pi and I add it to pi over 3, well, I know that this one is 3 pi over 3, and when I do add that, I do get 4 pi over 3. Wow, that's a lot of information. So I'm going to take my r, well, let's write z is equal to r times the cosine of theta. So I know that this is equal to the cosine of theta plus I times sine of theta. And we're going to put it all together right now. So I know that z is equal to 4 times the cosine of 4 pi over 3 plus I times the sine of 4 pi over 3.